Hello. In this and the final video of this tutorial series, I will go over how we can bring together all of the code that we developed into a simulation you can run. Before doing so, let's review the high-level schematic of your overall SPEGG project. You create a simulation class, as we discussed in video 1. This class initiates the simulation, reads in the basic parameters for your simulation, such as how many iterations to run from your simulation.conf file, instantiates your species and data logging objects, and actually executes the simulation. Videos 2 through 8 delved into how you can implement your species object to simulate the species subject to evolutionary change. These consisted of 4 main operations. First, we discussed in videos 3 to 5 how we can specify the genotype-phenotype map. Second, we described how you can simulate reproduction, which involves operations like choosing the parents, which we saw in video 6, and how genetic information is transferred from parents to offspring, as in video 7. In video 8, we described how we can update individual states in the simulation. Finally, in video 9, we discussed how we can specify our input files. Now let's briefly review our simulation class CPP file that actually carries out the simulation. You'll notice that we left a blank function run. The reason for this was that run is actually a very simple function, but its operations are easier to understand now that you know how your species object is supposed to work. Your simulation should run for a specified number of time steps. So, we will create a for loop that will iterate the simulation over these time steps. During each time step, we will call operations from our species object. Namely, you will need to call add kids to simulate reproduction. Next, you will need to call the update function to update every individual state in the simulation. Finally, you will call a function called removeDead, which is defined in the base class ins. removeDead is basically responsible for ensuring that dead individuals are removed from the simulation. Of course, you'll probably want to record the output of your simulation. For instance, let's say you want to have your simulation record what the mean phenotype across individuals is during the simulation. If you look in the definition file for our simulation class, we actually created a statistics class for doing precisely this. To record our output, let's modify our run function to include instructions for 1. Calculating the mean phenotype of individuals in a given DEEM at each time point, and 2. Printing the output of that calculation. And that's it. Your simulation class is good to go. To actually run our simulation, what you want to do is create a main file, which we'll call main.cpp. Let's examine the main.cpp file. We'll have the main file invoke what is called an entry point function. In C++, this entry point function is declared as int main void. Inside this function, we'll define a simulation class object, which we will instantiate with new. This calls the simulation class's constructor. Recall from our earlier video that this will perform a handful of operations. First, it will read in the basic simulation settings, like how many time steps the simulation will iterate itself. Second, it will initialize our key classes, including the species object. Then we'll have the program run the simulation by calling our run function that we just discussed. This will actually perform the simulation and record the outputs at each time step. Finally, we'll call the destructor by deleting the instance of our simulation class object. The simulation is almost ready to run. However, we still need to generate an executable for our simulation that we can call from the command line. So at this point, open a terminal on your machine and navigate to the SPEGG directory. Then, type make. Now what this will do is create a bunch of object files that include the main functionalities and classes of SPEGG. You can use these object files like you would any software library by linking your eventual code to them. As of early 2017, SPEGG has an experimental branch called Build Tools that contains scripts to help you build an executable. These tools are still under active development, and in the future, these tools might be included in the main SPEGG branch. But for now, you can use these tools in your local SPEGG working directory by typing in the command line git checkout build tools. Now navigate into the build directory from the SPEGG codebase. There, type the command /speggconfigure.sh. When prompted for the directory to our customized code, we'll type /demo species, where /demo species is the path to the code files for our customized model. This will generate a make file based on all the code you added. The make file is the file responsible for compiling your code into an executable. For details about how this make file works, please read the online tutorial. We'll copy this draft make file for the custom model into the directory where demo species is located and rename it as make file. Then you run make, which generates the executable for running your simulation. By default, this is called SPEGG simulation. You can run this executable by typing the command /SPEGG simulation, and you can now run your simulation. I also want to point out that you can copy and paste the make files from the example directories in the SPEGG branch and manually modify these to refer to the code files in your own simulations, for instance by changing the hill climber references to demo species references. So that concludes our demonstration videos for how you can get started using SPEGG. Thank you again for your interest, and if you have any questions, please post to our mailing list speg-users@googlegroups.com.